Right now, at this very moment, you're probably wasting more water in your garden than you're actually using. And the shocking part? You're paying for every single drop that never reaches your plants. What if I told you there's a method so effective that it saves up to 70% more water than anything modern technology can offer, and it's been hiding in plain sight for 4,000 years? Stay with me, because what you're about to discover will completely change the way you think about watering your garden. Picture this. It's a scorching summer afternoon in 2026. You're standing in your backyard, hose in hand, watching water spray across your garden. The sprinkler spins rhythmically, creating perfect arcs of glistening droplets. It looks efficient. It feels productive. But here's what's really happening. Before that water even touches the soil, nearly half of it has already vanished into thin air. The Environmental Protection Agency confirms that 30 to 50% of water from traditional sprinklers is lost to evaporation and wind drift before reaching the ground. For every 10 gallons you're paying for, 5 gallons might never make it underground where your plants actually need it. Your water bill climbs month after month. Those modern drip lines you installed, they're clogging, breaking, and ironically, feeding the very weeds you spend hours pulling every weekend. Meanwhile, your tomatoes are still thirsty, your soil turns to dust if you miss a single day, and you're trapped on a treadmill of endless watering, weeding, and worrying. But what if ancient farmers already solved this problem millennia ago, and we simply forgot? Modern irrigation isn't just inefficient. It's fundamentally broken by design. When you turn on that sprinkler, you're creating a problem that compounds itself daily. As water arcs through the air on a hot afternoon, ultraviolet rays heat those droplets instantly. Wind catches the fine mist and carries it away. The result: massive losses you never see but always pay for. Thousands of gallons per year, vaporizing into the atmosphere while your water meter spins. In 2006, outdoor watering has become one of the biggest drivers of residential water consumption. During summer months, it can double or triple your household usage. Nearly 1/3 of your average water bill goes straight to the yard, not to your showers or kitchen, but to ground that drinks it up and asks for more the very next day. And then there's your time. If you're a home gardener, you know this routine. 20 minutes in the evening, half an hour in the morning, day after day. Miss one session, and the soil cracks. Miss two, and you're looking at wilted plants and a season's worth of work circling the drain. A typical growing season consumes 20 to 40 hours just keeping plants from dying of thirst. Then there are the weeds. Every time you soak the surface, you're ringing a dinner bell for every dormant seed lurking in your soil. Within 48 hours, your garden beds erupt in green nobody planted. Research shows that in surface-irrigated gardens, up to 30% of all labor time is spent hunched over, pulling weeds that thrive on that easy surface moisture. The more you water, the more weeds appear. The more weeds you pull, the more time you spend fighting an endless battle. It's exhausting, expensive, and it doesn't have to be this way. Now, let me take you back 4,000 years. Long before plastic, before industrial agriculture, farmers faced a problem we're rediscovering. How do you grow food when every drop of water is precious? Their solution was elegant. Take an unglazed clay pot, bury it in the ground, fill it with water, let physics do the rest. The first written record comes from China, around the 1st century BCE. The Fan Shengzi Shu, an agricultural manual that survived for over 2 millennia, describes this practice as a proven method for survival, a way to coax crops from dust when the heavens refused to cooperate. Centuries later, the Romans were doing the same thing. They called these vessels Olla, the Latin word for round-bellied clay pots found in every household. Archaeological excavations across the Roman Empire have unearthed these pots, still buried in ancient garden plots, their porous surfaces stained by mineral-rich water. But here's what's fascinating. This wasn't just a Mediterranean invention. Across completely separate civilizations, the same solution emerged independently. In Iran's arid highlands, India's dry plains, West Africa, Brazil, and the American Southwest, indigenous communities discovered and perfected the exact same method. When Spanish conquistadors arrived in the southwestern United States, they recognized the buried pots immediately. Pueblo and Hopi gardeners had been using them for generations, keeping crops alive through brutal desert summers with barely any rainfall. This convergent evolution tells us something important. When water is scarce and survival depends on efficiency, human ingenuity arrives at the same elegant answer. Let the soil and the plant decide when to water, not the farmer. So how does a simple buried pot outperform thousands of dollars worth of modern irrigation technology? The answer lies in a beautiful dance between physics, soil, and plant biology happening invisibly beneath your feet. Imagine pressing a completely dry sponge onto a puddle of water. The water rushes in immediately. You don't have to squeeze or force it. The sponge is thirsty, and water naturally moves toward that thirst. Soil works exactly the same way. When it's dry, it creates what scientists call soil moisture tension, an invisible pulling force that draws water from any nearby source. The drier the soil gets, the harder it pulls. Now picture that unglazed clay pot, buried and filled with water, surrounded by roots and earth. The clay is riddled with microscopic pores, too small to see, but perfect for allowing water to pass through slowly. These tiny pores act like thousands of microscopic valves. When the surrounding soil is already moist from recent rain, the soil moisture tension drops. There's no pull. Water stays safely inside the pot, waiting. But as soon as plant roots begin drinking and the soil dries out, that tension increases. The soil literally creates a gentle vacuum, pulling water through those microscopic pores in the clay wall. The flow is slow, steady, drop by drop. And here's the magic: it's completely self-regulating. Researchers using precision instruments find that water only moves when the tension outside the pot reaches a specific threshold, typically between -10 and -33 kilopascals. That range is called field capacity, the sweet spot where soil holds just enough moisture for roots to drink freely, but not so much that it becomes waterlogged. This means the plant is always in control. Your sprinkler is like someone throwing buckets of water at you from across the room, hoping some lands in your mouth. The buried clay pot is like having a water bottle pressed directly to your lips, releasing water only when you drink. And there's another benefit. Because water is released below the surface, the top layer stays mostly dry. Remember those weeds? They need surface moisture to germinate. When the surface stays dry, weed seeds remain dormant. Your vegetables get water deep at the root zone, while potential weeds never get their invitation. No pump, no timer, no electronics, just physics. Working 24/7, responding to plant needs with precision no mechanical system can match. This sounds almost too good to be true. Does it actually work better than modern technology when measured properly? According to recent University of Arizona, set up a controlled experiment. 2 identical garden beds, same soil, same crops, same sunlight. One bed was watered traditionally. The other used a single buried clay pot. They measured everything, every liter, every day. By season's end, the surface-watered bed consumed 95 liters. The clay pot bed, just 30 liters. That's 68% reduction for identical yields. Scientists buried moisture sensors at multiple depths and distances, creating a 3-dimensional map of water movement. Around the buried pot, sensors showed stable moisture, maintaining field capacity constantly. This extended roughly 30 centimeters before dropping off sharply. Beyond that, bone dry. The surface-watered bed showed wild fluctuations. After each watering, sensors spiked to saturation, then crashed to dangerously dry levels as water evaporated. Plants spent half their time drowning, half desperately thirsty. When researchers dug up the clay pot beds at harvest, they found something remarkable. Plant roots had reorganized themselves, forming a dense white mat wrapped around the clay pot, following the consistent moisture with laser precision. This isn't theory. This is measured, documented, repeatable science, proving a technology from 2000 BCE outperforms anything from the 21st century. If this method is so effective, why did we stop using it? The answer has nothing to do with efficiency and everything to do with industrialization. After World War II, the chemical industry had massive capacity, with no battlefield to supply. Polyethylene became cheap and abundant by the 1950s. Plastic pipes, hoses, and drip irrigation lines flooded the market, promising convenience with perfectly manicured lawns in every advertisement. But these systems weren't designed for root-level efficiency. They were designed for industrial-scale agriculture. Modern farms operate on hundreds or thousands of acres. Tractors and harvesters need clear, unobstructed soil. Burying thousands of fragile clay pots would be catastrophic. Plastic lines could be unspooled, repositioned, and replaced as needed. They were built for scale and mechanization, prioritizing acreage over precision. That industrial solution quietly became the default for home gardens, too. The same hoses designed for commercial fields became what we used for backyard plots. There's another cost we didn't anticipate. Studies in 2026 find hundreds, sometimes over 1,000 microplastic particles in a single kilogram of topsoil. Where from? polyethylene and polypropylene, the exact polymers in drip lines and hoses. Unlike clay, which returns to earth as inert minerals, plastic fragments indefinitely. It doesn't disappear. It accumulates and enters the food chain through our vegetables. We didn't abandon clay pots because they stopped working. We abandoned them because they didn't fit industrial agriculture's blueprint. We're only now realizing what that trade-off cost us. If you want to bring this ancient method into your 2026 garden, how do you actually do it? It's remarkably simple. You just need unglazed terracotta pots and willingness to try something different. Choose your pot carefully. It must be unglazed terracotta. Those smooth, shiny glazed pots won't work. The glaze creates an impermeable barrier. Frost-proof pots are usually too dense. You want traditional low-fired clay with a porous surface that feels slightly rough. Before burying, seal the drainage hole at the bottom with a cork, clay plug, or waterproof putty. You want water to seep slowly through the clay walls, not rush out the bottom. Dig a hole so only the neck or rim remains visible above ground. Fill the pot with water, then cover the opening with something that blocks debris and mosquitoes. A terracotta saucer works perfectly. Arrange your seeds or transplants in a circle roughly 12 to 18 inches from the pot. This is your reliable moisture zone. In sandy soils, water might spread farther. In heavy clay, slightly less. For a typical raised bed, one medium pot, about 8 to 10 inches in diameter, covers a circle roughly 3 feet across. Larger gardens need multiple pots, spaced so their moisture zones just touch. You don't water the plants, you water the pot. Simply top off the buried pot every few days, and the soil handles everything else. Most pots need refilling about once a week, varying with weather and crop type. If your pot empties in a day, it's too small or you're dealing with extreme heat. If it stays full for over a week, your plants might not be established yet, or recent rains satisfied the soil. Practical warnings: terracotta is fragile. Don't step on buried pots. In hard freeze regions, drain and lift pots before winter. Hard water can clog pores. A vinegar soak restores flow. This works beautifully for vegetables, herbs, and annual flowers. Large woody perennials with aggressive roots might eventually crack the pot. Let's zoom out. Why does this matter beyond your backyard? In 2026, water scarcity isn't a distant threat. It's current reality. The American West faces mega drought conditions. Reservoirs hit historic lows. Aquifers that took millennia to fill are being drained faster than they can recharge. Simultaneously, microplastics have infiltrated everywhere, from ocean trenches to Mount Everest's peak, to our food and bloodstream. A significant source? The very systems we use to grow food. The buried clay pot method offers genuinely sustainable technology. It cuts water consumption by 70%, eliminates plastic irrigation components, requires no electricity or batteries, no electronic controls. Most importantly, it reconnects us with a fundamental principle: industrial agriculture obscured. Plants don't need complex management systems. They need consistent root zone moisture. Give them that, they do the rest. The clay pot is humble technology. No app, no firmware updates, no subscriptions, just clay, water, and physics working together for 4,000 years. But don't mistake simplicity for primitiveness. This is sophisticated design from deep understanding of soil science, plant biology, and hydraulics. Our ancestors weren't less intelligent. They had different constraints and values. When water was precious and waste unthinkable, they created systems reflecting that reality. We're arriving back at those same constraints. Waste unthinkable again. The solutions they developed may be more relevant in 2026 than at any point in the last century. So here's where we stand. You can keep doing what you've been doing. Keep dragging that hose around every evening. Keep watching half your water evaporate. Keep pulling endless weeds that sprout from surface moisture. Keep paying water bills that climb higher every summer while your plants remain thirsty. Or you can try something radically different and transformative. Something proven by 4,000 years of human experience across every continent and culture that faced water scarcity. The buried clay pot won't solve every gardening challenge. It's not magic. But what it does significantly better than anything else available. It delivers water with surgical precision, eliminates waste, dramatically reduces labor, cuts costs, and does it all without electricity. Sometimes the most genuinely advanced technological solution is the one that was never supposed to become obsolete. The knowledge is readily here. The science supports it overwhelmingly. The pots are at your local garden center. All that's missing is questioning whether newer always means better. Your garden is waiting patiently. Your water bill is waiting. Physics is ready to do the work you've been doing manually for far too long. The best irrigation system truly listens to the plants, responds directly to their needs, and wastes absolutely nothing in the process. The future of truly sustainable gardening might just look exactly like its ancient past. That humble ancient clay pot might be the most revolutionary technology in your entire garden today.